the first video in math skills to ace chemistry. The first thing we're going to talk about is significant figures, which is one of the biggest concepts that are going to be used, whether it's in introductory chemistry, so like Chem 3A, or General Chemistry 1. You're going to be seeing this a lot, and you might have a professor or instructor that's really going to be trying to make sure you use these correctly. And that's because they're very important in chemistry, in any science class, not only chemistry. The big reason is it teaches scientists such as yourself or future health professionals that we need to show how inaccurate our measurements are because we want to be honest. That is the whole idea about science, is that it needs to be truthful, and so that way we can trust each other as a scientific community or as a global community for advancing and for helping those around us. So when it comes to significant figures, the big idea here is that, well, if I kind of take this one analogy that I like to use in a lot of my classes, and that is, if you remember that famous scene from the Indiana Jones movie where there's this gold statue in front of him, and all of a sudden he decides to swap it with this bag that just happens to be the same weight as it and doesn't trigger the trap. Well, I mean, in the movie, it still triggers the trap, but the whole idea is, well, if this is a 20-kilogram statue, well, what do I mean by that? Saying 20 kilograms. What does it mean? Is it just 20, or is it 20.0, or is it 20.00? All these extra zeros, sure, they all represent 20, but they represent a different amount of precision that was used in that measurement, meaning that it costs a little bit more to get those extra zeros. So if you're taking the time to really get those full amount of significant figures, like on the example on the right-hand side up here, well, that's something that you want to show that, right? And you want to be honest. So the whole idea is that all these are based on measurements, meaning that we take measurements in the lab, whether it's chemistry, biology, and a clinic or like in a more practical setting, we're always taking measurements. So it's based on whatever glassware or whatever scales that we're using or instrumentation. That is what it's based on. So when we are going through these, let's say if you take one of the simplest things that you've done at some point in your life, which is most likely you've used a ruler, right? Whether it's maybe measuring a room or measuring the length of something. The big thing when it comes to a ruler is that you might see that there's these different gradients or lines that are on it. And those different lines, they always represent tick marks, meaning they tell you how accurate or how precise this ruler is. And one thing is, like, if you might maybe notice, is just by looking at this thing, well, we have different tick marks all along this device here. Well, this represents how precise this ruler is, meaning that if I kind of look at this, well, all right, I can read, all right, this is 13.1, this is 13.2, 13.3, and all the way up to 13.5. But if you notice this red line that I have right next to it, well, that's kind of not really falling on 13.5. Do I just say 13.5, let's cut there and be happy? No, you don't want to do that. Or if you're building something, someone's going to get really mad that the measurements are off. So you want to make sure that things are measured properly. So if we look at that really closely, well, this is where approximations come from with certainty and uncertainty. So to summarize that, tick marks, they tell you how certain you are with your measurement. Meaning that if I look at this, I was able to tell for a fact that it was at least up to 13.5, right? Based on those tick marks. So these are our certain values. However, if there is an area where you fall in the middle, or even if you fall in the line, we always are able to approximate one digit past that tick mark. So meaning, in this case, if I said like, okay, well, I'm going to approximate that this is at maybe 13.52, 13.53, any of those values are reasonable because it's your measurement. You are the scientist. You can approximate it however you're seeing it with your eyes. And that's the whole idea here. So these are all representing significant values that are, whether they're approximate or they're certain, right? So we have certain, approximate, or if you want to say certain and uncertain, that's okay too. These are all representing significant digits, or significant figures because you took the time to measure that value and to show that in your measurement. So this is what we're going to be going into. Measurements dictate how significant something is. So when we're looking at these, this not only does it indicate how many sig figs there are, but they indicate the precision of the instrument you're using. In this case, we used a ruler, right? So whatever you're using, you need to show that. So that way, whoever is seeing whatever your results are, they know if they can trust them or not. And it's not a bad thing if they're not up to someone's standards. You did the best that you could with what you had, but you're being honest. So that way you can see if you can improve yourself. So the whole idea here is that when we move forward is that we're going to go through a bunch of rules for counting sig figs. Meaning that if I go through that measurement in the past, well, there were a number of sig figs there. So that goes off our first rule. And then what that says is that all non-zero digits and zeros that are sandwiched by non-zero digits are significant. You're like, what the hell is he talking about? What is that? Well, a non-zero digit, well, think of the word non or not zero. So that's everything that's like 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So just counting with your fingers. So they're not zero. So all of them are significant values. Now, if these, let's say if we have like 1 and 3 and that's sandwiching a 0, the 0 is now significant. And that's because it depends on where zeros are. All sig figs are all based on zeros. So if we kind of go up to above to that measurement we took, well, being that all non-zero digits are significant, what this tells you is that, oh, well, we have 1, 2, 3, 4 significant figures in our measurement. So we went to 4 total sig figs. Let's look at more examples and try to make this a little clearer. So if I go back down and I go to the following examples, well, I have this rule here, right? All non-zero digits and 0 sandwich. So if I look at the first one, all right, well, it's 123.4. All of these are non-zero numbers. So when we count this, right, we have 1 sig fig, 2 sig figs, 3, 4. So what is our answer? We have a total of 4 sig figs. If I look at the next one, this 0 in the middle, this is referred to as a sandwiched 0. And that is because we have ones on both sides, right? It's a 1 sandwich. So if we want to count the number of sig figs, we have 1, 2, 3. So we have a total of 3 significant figures in this calculation. And even with larger numbers, we can count how many significant digits there are because it tells you how precise that result is. So if I look at this next one, right, I can see we have 1, 2, 3, 4, 5, a sandwich 0, 6, and 7. So that's also sandwiched. So we have a total of 7 sig figs, right? So they are all present. So that's fantastic, right? So we're just counting. And that's the best part. It's only a counting tool to make sure that eventually when you start doing math, that you have the same number of sig figs at the end that you started with from your measurements. These represent your least precise value in the end. So rule number 2, trailing zeros are significant if the number has a decimal place. So when you put a decimal there, all of a sudden it gains significance. But keep in mind, we still have the rules from earlier. All zeros, they have to be sandwiched too. So if you don't have a decimal, like let's say here in this case, right, there's no decimal place there. So are those zeros significant? And the answer is no, they're not. It's just we only have one significant value here. So does that change that number? No, it's still 100, but it's just telling you that that first digit is significant, meaning that it could be an approximation. It's still the number 100. Those zeros are just placeholders to tell you, oh, it's a big number. Now, the second I add a decimal to it and say 100 point, and that's more like, no, it's 100 on the dot. That's how much you need. That, like, let's say if this was money and we had to say, no, you owe me $100. That's something that you're exactly saying. It's exactly 100. So when we count that, because of the decimal place, and this is a little math trick that you're going to see sometimes, is that this makes it 3 sig figs. It's showing that that is actually measured correctly. And the same thing here on the next example. Well, we still have that decimal place. So, and being there's zeros afterwards, these are referred to as trailing zeros when all of a sudden they're after the decimal. Well, it's still showing that it's very accurate. Someone took the time to make sure that you knew that we had 4 sig figs of value. They wanted you to know this is a good calculation, or sorry, good measurement. All right, next one, the last rule. So we have the following rule. Rule number 3. For a number smaller than 1, meaning that it starts with 0 point something. So think of maybe like pennies, for example. Let's say if you're counting change and you don't quite have $1, that's what that means. It's something very tiny. Leading zeros are only placeholders. So a leading zero is like the 0 up front, or it's not an actual non-zero number. It's just a placeholder. So they're not significant. Just because it's a tiny number doesn't automatically make every single number significant. But trailing zeros are significant due to the decimal. So it takes in rule number 2. It kind of combines the two. So looking at the following one, right, we can see we have 0.9. Well, how many sig figs do I have? We have 2 places here, but only one of them is significant. Only the 9 is a significant value. The 0 is just telling you it's small. So all we have here is 1 significant figure value. Now going to the next one, well, it's the same idea here, is that we have 2 placeholders up front. It's just telling you it's a small number. So we start counting at the first non-zero value. And being that we have all these trailing zeros, these are all significant. So what does that tell you is that trailing zeros are sometimes significant. So these are always sometimes. Depends on the decimal. So if there's a decimal there, then they are. Leading zeros are not. Okay, so leading, which is up here, are not significant. So if we go to the next one, you can see that we have a bunch of leading zeros here. Spelled leading wrong. That's always fun. So leading zeros, they're just placeholders, just telling you it's small. So we only have 1 significant value, but 4 placeholders that are here. So that's the whole idea when it comes to significant figures. So just a kind of quick little recap of what these different zeros mean is that, all right, well, we have a couple different types here. We have what we refer to as trailing zeros. So if I have the 55900.0, we have some trailing zeros, and these are sometimes significant. In this case, yes. And that is because of this decimal here. So that makes it all of a sudden it is significant. Versus the next example, this one is a big no right here. And that is because of the same reason. There's no decimal place here. So this is also a trailing zero. Now, in this number, we have a couple different types of zeros as well. We also have leading zeros up front, right? Are these significant? And the answer is no. And then we have sandwiched, which is a yes. So if we go through both these examples, how many sig figs do we have? Well, on the first one, right, we have the non-zero digits. Then we said all these trailing zeros are significant in this case. So we have a total of 6 for the first one, for the 5,000 or 55,900 number. And then for the next one, we have 0.00020020. So where do we start counting? At the first non-zero value. So we have a total of 5 sig figs. And that's how we do zeros. And that can be some of the hardest parts. So the last thing when it comes to significant figures has to do with counting. And I know we've been counting this whole time, but this has to do with actual counting. So what I mean is if you count an exact number, like there's no ifs, ands, or buts, like if I count how many people maybe are in your house right now, and I say, well, there's you, maybe your mom and dad, so maybe there's 3 of you, right? So there's 3 people in this house. There's not 3.5, there's 3, right? If you want to count how many books there are on your bookshelf, well, maybe you count 20. Well, there's 20. Or if I have the example that I have here with my avocado friend here, and it says if a farmer counts 12 avocados, well, how many significant figures are in that measurement? And you're gonna be like, well, Dr. Dan, isn't it just 2? Like, that's what we've been doing this whole time. The thing is, it's actually not 2, and you're gonna be wondering why. And that's because it's an exact number. So what that means is that there's an infinite number of possibilities for the sig figs. You can have as many options as possible. And the whole idea is that this goes across a few different things. And that's if it's counted, if it's a formula, or if it's a definition, meaning that it's based on however you as the scientist want to define that definition. And like, if what I mean by that is, well, if I go back to my avocados, well, if I say I have 12 of them, I can say I also have 12.0. I could also say I have 12.0000 and keep going. And all of these will have a different number of sig figs associated with them. And depending on how you use it in your calculation, the whole idea is that it's not going to affect the calculation because you can define those number of sig figs however you want. So if you can, and the idea is that you want them to be more sig figs than your least accurate or least precise measurement. And that's the whole idea about sig figs. So that's going to be the last part of this particular video. So stay tuned and I hope you enjoy the next one. If you have any questions, feel free to comment in the section below. Please like and subscribe. And I hope this video helped and I'll see you all in the future. Thank you so much. I'll see y'all later. Bye.